continue to see gel electrophoresis. If you are not a member of Media Academy, subscribe the video. But if you are already a member of Media Academy, like and share the video. Let us continue. Gel electrophoresis. Electrophoresis is a general term that describes the migration and separation of charged ions under the influence of electric field. You know, under the electric field, there is anode and cathode, positive and negative charge. Due to this charge influence, whenever you put the substance show the movement, either to the cathode or anode. So why we electrophoresis? The first question. The reason is to separate DNA fragments from each other. Again, also to determine the size of DNA fragments, to determine the presence or absence of DNA, to analyze digestion or restriction digestion products. This is the reason why nowadays gel electrophoresis is used. Gel electrophoresis can be agarose or polyacrylamide. Agarose gel electrophoresis is a method to separate either DNA or RNA. This separation is based on size and charge. This can be achieved by moving negatively charged ions toward positive. That is what you call agarose gel electrophoresis. Agarose is a kind of substance that can be obtained from algae. It could be prepared by mixing with a buffer, then it forms something like a jelly. Then it will be put in the chamber. After that, electric field could be applied. Then the molecules, DNA or RNA, can show migration. As I have said, the separation is based on size or a charge. Mind you here, shorter molecules migrate faster than longer ions or longer ones. You know that DNA is a negative charge because of phosphate. You know, DNA is made up of sugar phosphate backbone. The phosphate here is a negative charge. Because of that reason, when you put the molecule of DNA in the chamber, it moves to the anode, which is a positive charge. What are the materials to carry out what you call electrophoresis? The first material is electrophoresis chamber, agarose gel, gel casting tray, buffer, staining agent, comb, DNA ladder, and the sample to be separated. These are the materials. The first material is agarose. Agarose is nothing but it is a polysaccharide or a carbohydrate which is extracted from algae. It forms a porous matrix when it's gel. This agarose can be prepared by solution by adding a buffer. Then we melt it up to temperature of 40 degrees centigrade. At that time, it forms what we call a gelling agent. Gelling. Do have some porous matrix. So it is through this the migration of these molecules can be carried out. In gel electrophoresis, the other very important material is ethidium bromide. This ethidium bromide it is very important to visualize DNA after electrophoresis. You know, in chamber, DNA molecules moves from cathode to the anode. Then this ethidium bromide is applied. It helps to visualize the DNA bands. Mind you, when you say a band means in the band there may be a number of DNA molecules. It does not mean that a single DNA. It means not that the band is equal with a DNA. In a given band, there may be many molecules. The larger band moves slower, the lighter band moves faster toward the cathode. Toward anode. So the movement is based upon size and a charge. This ethidium bromide visualize that band in this electrophoresis. Actually, this chemical is very mutagenic agent. It may cause a cancer anyway, but it is very important to visualize the band. The other very important instrument is casting tray. It is composed of UV transparent plastic. This can be prepared by dissolving agarose powder in a buffer such as TA or TBA, trace base acetic acid, and EDTA, which is used in electrophoresis. Then heating up to 40 degrees centigrade of temperature, it forms what you call a gel. Then a comb is very important. This comb is placed in a liquid agarose after it has been poured in casting tray. Then after combs are removed, it becomes hardened, it becomes solid. So it would produce a series of wells, which is used to lose the DNA sample. The other very important is DNA ladder, which is consist of DNA size, which is known DNA size used to determine the size of unknown DNA sample. Unknown DNA sample. It is known, it used to determine unknown DNA sample, which is poured into the gel. Applied voltage. This applied voltage is increase rate of migration. Just once all materials are prepared, applying the electric is very important. That is what you call applied voltage. Then the molecules show the movement. For that matter, what are the methods to prepare agarose gel? We have to melt, we have to add ethidium bromide, then pour into a casting tray with a comb, then remove a comb, solidified. After that, adding the buffer. Actually, buffer is very important to maintain the pH. Then run the gel at a constant voltage at the band separation occurs. Finally, view the band in the UV light here. The band in the UV light here. The larger molecules migrate slowly. The smaller molecules migrate in a fast. This is a DNA band. It's known size. For example, here is a sample 1, sample 2, sample 3, sample 4, 5, and 6. These are wells. This is a DNA ladder. Here, for example, the size of the sample 4 is 500 base pair. The size of sample 5 is also 500 base pair. The size of sample 2 is 2500 base pair. The size of sample 3 is 3000 base pair. So the larger molecules migrate slowly. It remain here. This is a band. In this given band, there is so many DNA molecules. It moves slowly. This move in a fast. Actually, agarose gel electrophoresis is very important to separate the DNA and RNA molecules. What about in protein? In the case of protein, ACDS page is very important. Sodium dodecyl sulfate polyacrylamide gel electrophoresis. This technique is important to separate the protein based on the weight and the charge. Actually, proteins are aphoteric. It means that they show negative and positive charge. Some amino acids are positive charge, the others are negative charge, the others are both negative and positive charge. They are aphoteric. Separation is not easy like DNA. So the separation of charging molecules depend upon relative mobility of charging species. Smaller molecules move faster than larger molecules, just like DNA and RNA. Materials are the same. Gels are very important. Chambers are very important. The samples are very important. Here, the chemical mercaptoethanol is added to reduce disulfide bond. You know, protein do have disulfide bond. That bond should be reduced. That bond should be reduced for separation. Buffer is very important. Buffer is very important. ACD is also very important. Again, COMAS, which is stem buffer, is very important to view the protein in a gel. Just like DNA, protein ladder is also, it is a reference protein ladder which is used to determine the location of protein interest based on molecular size. Actually, the structure of proteins and the charge of proteins are also influence the rest of migration. They are folded. These folded structures should be reduced by applying chemical mercaptoethanol. It reduces the bond of disulfide in a protein. Again, proteins are both positive and negative. For that matter, we have to apply ACDs, sodium dodecyl sulfate. This sodium dodecyl sulfate make a protein a negative charge. It make a protein negative charge, so it migrates toward anode. Assume that this is a chamber. These are the wells. Wells are here. This is a wells on which sample can be inserted. Here, the ladder proteins. These are the ladder proteins, which is known size. Let this be 100. This could be 200. This could be 300. This could be 400. Mind you, this is a size. This could be 500. Then the last could be 600. Once we prepare all things, we put the sample here in a wells. This is a wells. Wells is a place where we put the sample. This is a wells. We put a sample here. We used ACDS. This ACDS make a protein negative charge. This is a positive charge. After we finish all things, we apply electric field. This is a negative charge. This is a positive charge, which is anode. This is anode. This is anode. This is anode. This is a cathode. This is a cathode, which is a negative charge. Log. This protein migrate here. This one reach here. This one reach here. Again, log. Mind you, we applied the electric field. After that, the molecules run in the gel. The larger molecules migrate slowly. Lighter molecules moves quickly. So these are reporting here for this sample. This is also reporting for this sample. This is a protein for this sample. Its weight is 500. This one is 400. The last, which moves fastly, is 100. We do have small size. So this is the chamber. We applied electric field, then we run. Smaller molecules migrate fast, larger molecules migrate slowly. So that is how proteins move. Thank you very much. Thank you very much.